Welcome back, everybody.
Yes.
Folks feel rested and refueled with good food and good sleep? Good. I hope this activity this afternoon will be fun. It's one I've done before, and I think it should be good. But we just have a couple things to cover before we get to it. So just to refresh our memory for where we were before we ate too much tasty lunch, we were talking about heredity and how genes and alleles are passed from parent to offspring.
So now we're going to
And the main thing that I wanted to make sure that we were all comfortable with is that because DNA is passed from parent to offspring, traits are also passed from parent to offspring. And through assessment, you all seemed fairly comfortable with this, so we moved on. So now we're going to look at how mutations can change the frequency of a trait in a population over time. To do that, we have to just make sure we understand a couple more things about mutation. You all are going to be experts at mutation by the end of these 2 days. Just so you can, just to make sure you are aware, we're now moving into our concept invention or the explain part of this second learning cycle. So, like Miguel talked about yesterday, mutations are happening all of the time, and you should understand now, after looking at the nature of how mutations happen, that they are random. The changes in the DNA are random, and they don't correlate to any specific trait. It's kind of random which change in your DNA. The changes in your DNA are random, and those cause the changes in traits. And because they're random, most of the mutations that you would encounter are going to be either neutral or deleterious. So, just as it's pretty rare you would roll a really good dice hand, it's pretty rare that you would get a mutation that really helps you out a lot. But it does happen occasionally. When you have a mutation that is beneficial for an organism, we call that an adaptation. I'd like you to talk in your tables just briefly for like 1 or 2 minutes. What determines whether or not a mutation is beneficial or not? Cool. So 2 minutes. I gave you a hint in this picture Just so you can look at this picture, you might have a hint.
다 단다 버리지도 버리 될라 따와네 단다 뒤와되기 내라 yes 상다도 which 되고레스.
But go ahead and talk, and we'll bring it together in a couple minutes.
까마치 나 저도 제스네.
Yeah. What makes a mutation? What determines whether or not a mutation is beneficial or not?
다 단다 연주디 케빈 연매지 가르게 타 주고레스. Natural selection.
Natural selection. Yes. Say more about that. Yes.
이거야 또 스마트폰으로 치다스. 던줄. 아. 던줄로.
코리를 던질치다.
Adaptations.
Adaptations. So what makes it an? Yes, that's right. But what makes it an adaptation?
다 던줄에라서 가르기 던줄 세우레베스.
What determines whether or not it's an adaptation or not?
단다 던줄 인다 메시아데 가르기 양 타 주고레스. 손에 fitness.
Fitness. Yes.
네, 딱다레스.
That's true. You're close. I'm looking for a little more though.
Trait. Determined by trait.
The trait. Okay, let me ask it a slightly different way. This mouse, let's say this is the original color of the mouse fur.
답변 시작인 다스 리모저라 니 단다 찌찌디기 카도 토마저라 코나 되메기 카도 디바 차쇼스.
And then there is a mutation for dark fur.
데니 디젤라 년주 조레스 년주 가르서와나 거기 불라 년주 조체 뿌디 나고 차브레스.
Is dark fur adaptive in this environment?
다 단다 코나기 뿌 나고 차소 뿌 나고 찬조 디 단다 코이 디 나로라 뛴주 조투고레베스.
No. Is dark fur adaptive in this environment?
데니 코나고 뿌 나고 디 단다 코이 디 나로 뛴주 야고 조투고레베스.
So what determines if a mutation is adaptive or not?
다 단다로 단다 뛴주 단다 디로 년주 디 코이 지 나로라 케베 연매데 가르기 타 주고도스. 코이 determined by environment.
Environment, yes. Yeah, the environment is what determines how natural selection works. So all of those words you said about fitness, adaptation, natural selection, those are all true, and I was looking for what drives those things, and that is the environment. The environment drives all of those things that you mentioned.
다 단다 강라 참마가질네 단지 개가 망보송서 디 차장라 뛴주당 디소라 차장 딱다 레거래 이니야 조조데 간에서 디소 차장 용하야데 가르를 세와이나 뛴주도서 쿠유고 왕고 정고레스 단다 된날네 도도디 쿠유게 왕게레스.
So I just want to review the classic case study of how environment can drive natural selection. I'm sure you've all seen this before, but I think it's worth refreshing before we do our activity.
다 단다 교나서 예마가 디 망보 통사 예제레스 단다 빼지 땡야저라 그래서 차장 간에서는 이내양 디 예마 교나 망보 통화 이내양 디 렌타 점바 야자 따야 데 렌타 점바 차더레스.
So in England, before the Industrial Revolution, there was a moth that is this color, kind of black and white.
This one.
Yes, the low one.
단다로 간에서나 단당가서 심부 처리세요 디 예마 인랭기 나로려야 추자리 마다위 nga로도스 코랑기 카도들이 요레스 나보 가보도 처리돼.
And occasionally, it has a mutation that makes it